welcome again to this one. Yesterday we spoke about finding the height of a tree and how that works and its complexity. Today we are going to be looking at something also very interesting. We are going to be looking at the print node at depth. Now, I just wanted to stop here and speak a bit about this chapter 9. Now, it's called stacks and queues, and that's very important that we also understand what those are. So basically, just to give you a rough but clear explanation, basically a stack is basically say four guys are standing outside, and the first guy comes in, the second guy comes in, the third guy comes in. So now they are like this, right, in the stack, and this is the first guy, but he gets to leave last if they want to, pop back out. So that's why we call this first in, that's a stack, first in, last out, right? So he's the first guy to come in, but he's the last guy to leave. Now, unlike a queue, so now a queue is more of different, because if we have four guys standing outside and this first guy comes in, the second guy comes in, the third guy comes in, the fourth guy comes in. Now there is an opening in the other end, so for this guy to say, "Oh, I'm leaving first." Now this guy cannot run past him to be the first guy. So for that reason, we call this first in, first out, right? So basically, that is the idea of what we are going to be dealing with, or we are trying to, see how it's advantageous to work with this rather than a brute force method. So yeah, just wanted to give that clear understanding of what we are going to eventually see in our optimization. So we carry on with this guy. Now it says print node at depth O of n, sorry, print node at depth. So we look at the node, right, of the binary tree. So it gives us a node and it gives us a depth. So what we're trying to simply do is print all the nodes at a depth. What do we mean by that? Say we have this binary tree. This is a depth of 0. Oh, sorry, depth of, yeah, this is the depth of 0, right? And this is the depth of 1, right? Naturally. Now, we have this guy over here as a depth of 0, and if if this guy is simply saying at this depth I want to print out everything on this line, which is 2 alone, and at this depth I want to print out everything on this line, which is 2. So basically, when you give it a depth, say you gave it this node at this, the root of this node, I told it, oh, give me everything on the depth of 1, basically it's going to give you these two guys. So that's what we are trying to achieve with it, and let's now see how we do that. Now we say if print node is none, return, right? So if it is maybe one of these low values, we should return. Now it says if the depth is equal to 0, so we should print out the node, because we found a node at a depth that is low, so we should print out that node, because that's what we came here to do, right? And then we go ahead to return. So let's just see that in play here. So we have this node and we are asked to print out the nodes at the depth of 1. We are given 2 here. We say, oh, we are given 1 as a depth and we are given 2 as the head of the node. Now we say, is this node none? So it's not none, so we continue. But is the depth 0? No, it's not 0. What do? We go to the left of the node and the right of the node, and then we minus 1 from the depth. The depth is 1, remember. Minusing 1 out of that will give you 0. Now we are here and our depth is 0, right? Because we've minused 1 out of it. So if you were wondering why this stuff was upside down, that's the reason. So we have depth at 0 now, and our depth at 0 for these two guys. That means we can go ahead and then print 1 first of all, and then print 3 second of all, based on the recursion. So we see left first comes before right. So we print that and then we return, and we see that we've printed these guys on this level. So the complexity of this still is O of n and O of A of N for time and O of N for space, because naturally for every depth we are going to go to, we still have to visit every node primary to it. So basically that's why we have O of N complexity for this. Muchas gracias. Auf Wiedersehen. Choose. See you on the next one.